I want to share 500, 8 tens, and 3 ones among with these 4 schools. There are enough hundreds for each school to get 100. That leaves 100 that I can't share. I'll trade the remaining 100 for 10 tens. That gives me a total of 18 tens. I can give each school 4 tens and have 2 tens left over. 2 tens are not enough to go around to the 4 schools. I can trade the 2 tens for 20 ones and put these with the 3 ones I already have. That gives me a total of 23 ones. I can give 5 to each school of the 4 schools. That leaves me with 3 ones as a remainder in all. I gave out to each school 140 tens and 5 ones, with 3 left over. You can look at division with an eye to partial quotes by using a version of a bar graph model blended with a repeated subtraction approach. 1,506 divided by 3. In this model, they broke it up into 200, 200, 100, and 2 for 502. And there's 3 groups of them. So 200 times 3 is 600. Subtract, you get 906. I do it again. Subtract, you get 306. Do it again, but this time times 100. 306 minus 300 is 6. 6 minus 6 is 0. So 502. On the left is the standard algorithm. To the right is the explicit trade method that matches the actual action with the models by explicitly recording the trades. Instead of bringing down the step of the algorithm, trade pieces are crossed out, as is the number of existing pieces in the next column. The combined number of pieces is written in this column using, in this case, the 2-digit number. In the figure in the example, 2 hundreds are traded for 20 tens, combined with the 6 that were there for a total of 26. The 26 is therefore written in the tens column. Students often find the explicit trade method easier to follow than the standard algorithm. After 5 times 5 makes 25, you subtract it from 26, there's 1. You bring the 1 over and bring the 3 down right beside the 26 to make 13. How many 5s in 13? 2. 5 times 2 is 10, so you go 13 minus 10. There's 3, so the remainder is 3. In activity 12.4, select a division problem with a 2-digit divisor, such as 936 divided by 18. Display a corresponding side chart of the products of the divisor. So 10, 20, 40, 80, all times 18. Then try to think about the division using a missing factors approach and repeating subtraction. See if this helps in estimation process. In the problem 3,842 divided by 14, they make a multiplication side chart. 100 times 14, 1400. 200 times 14, 2800. 400 times 14, 5600, which is way too much. But they even went 800 times 14 to make 11,200. So they figured out that it was closer to 200, so then it ended up being 274, remainder 6. What estimation would give you from 27 times 325? If you use 20 times 300, you get 6,000. Or might you use 25 for the 27, noting that 4 25s make 100. Because 325 divided by 4 is 81, that would make an estimate of 8,100. If you use 30 times 300, you get 9,000. Or 30 times 320, which gives you 9,600. Are all these right? Yes. Don't tell students there's only one way to estimate. Concert ticket is $37. There's 13 people attending, so we're going to round that to 10 to make it 370. Since there's 3 more, and it's around 40 to 37 to 40, so there's about $100 more they could get, so roughly 470. Using compatible numbers when estimating with division. So you have 1/8 of 60. 8 doesn't go into 60 evenly, so we round that to 64. 1/8 of 64 is 8. So about 7 or 8 winners. The front end. This method focuses on leading or leftmost digits in numbers. Once the first digit is identified, then the students think about the rest of the number as if they were zeros in all the other positions. Adjustments are made to correct the digits or numbers that were ignored. This method has been shown to be one of the easiest for students to learn. Rounding. This method is a way of changing the numbers in the problem to others that are easier to compute mentally. In multiplication, students can either round one number or both. Compatible numbers. This method refers to changing the numbers to one that would make the problem easier to compute mentally. This strategy is used in division by adjusting the divisor or dividend to close numbers. Many percent fractions and rate situations involve division, and the compatible numbers strategy is quite useful. In this activity, students are using a jump number, and they're going to estimate how many times they have to jump that number to reach a goal. Like 5, and then I estimate 10 times it would take to get to 72, which is 50. So did I reach my goal? No. In this activity, you can use calculators to estimate and check. Students can enter 0 plus the jump number and press equals once for every estimated jump, or multiply jump number times estimated jumps. We have 17 and a target between 800 and 830. If the first number is 25, 17 times 25 is 425. It's not in the range. Then the calculator is passed to the partner, who clears the screen and picks a different number. For example, a number close to 50 because the first product was about half the number in the target range. A second estimate might be 17 times 45, 765. Closer, but still not in the range. The calculator goes back to the first person. Continue to clear each estimate or try again until someone gets the product that hits in the target range. Here we need to focus on the meaning of a zero in a number by starting with a number like 4005 and asking how would that be shown with materials. Using an approach that mimics addition. Return to the direct model using an array. Work back to show the links between distributive property of multiplication over addition, including the listing of the partial products. This is interpreting the regrouping of a number in multiplication. Have students move away from just using algorithms until he or she can explain it. Misuse distributive property in division. Go back to using smaller numbers and show with paper plates to represent the groups that the number of groups remains stable. It is the quantity of the items that need to be distributed equally that can be broken up into different collections to reach the correct answer. Ignore the internal zeros when dividing. Have students estimate the answer before starting. Will the answer be in the tens, hundreds, or thousands?